Differentiation is a tool in calculus that allows us to compute for the slope of a graph at any specific point. For example, for a linear function, its slope is simply a constant c, and differentiation tells that or reveals that directly. However, the power of differentiation lies on a non-linear function or a curved graph. Here, the slope of the graph changes at every point, such as here and here. Differentiation here let us compute for the slope of this graph at any point. It gives a way to measure the changing rate precisely. Methods of differentiation includes the chain rule, the product rule, and also the quotient rule.
Alright, so let's start with question number 2. 2a. So as we can see that there's actually two different function, which is e to the power of 2x square and and 3x cubed minus x plus 2. So these are two separate functions. So let u equals to e to the power of 2x square. So 2x squared is the inner function, so we'll be differentiating that. After differentiating that, we'll get 4x and then we'll multiply 4x with the original u over here, and then we'll get u prime equals to 4x e to the power of 2x squared. And then we'll do the same thing to the other function. We'll be differentiating them here. So this one only needs a basic differentiation. So 3x cubed minus x plus 2. So we'll be differentiating them like normal, and we'll get v prime equals to 9x squared minus 1 plus 0. The final one will be v prime equals to 9x squared minus 1. And then we have to use product rule to get the final answer. So all you have to do is just put the functions in. So let's say here u and v prime. So we'll take u here, and then v prime here. Let's put them there first. So it's on v u prime. So we're going v here and u prime here. So the equation will look like this. As you can see that both sides. So as we can see that both sides has e to the power of 2x squared. So we can actually factorize them and put the e to the power of 2x squared outside. So we'll get so the e is out of the way, so we can ignore that first. Ignore that. So we can just now expand the insides, which only has x, and after expanding all of it, we'll get this final answer. Yeah, that's about it for the first question. Alright, now let's move on to question B. Question B. Y is equal to ln sine 3x over 3 minus x cubed. So for this question, we cannot use product rule. We actually have to use quotient rule. Why? Because here we use product rule because there's two separate function, and you need to multiply it. The function multiply with each other. That's why we use product rule on this question. But on this question, it doesn't multiply. It's actually divide ln sine 3x divided by 3 minus x cubed. So that's why we use quotient rule. Alright, so this just like usual, there's two function. We'll separate it first. So let u become ln sine 3x, and then we'll differentiate them. After differentiating ln sine 3x, we'll actually get 1 over sine 3x multiplied by 3 cos 3x. This basically means that to simplify it, basically it's 3 cos 3x over sine 3x. So we can actually just simplify it more, and it can become 3 cot 3x, which is here, the final one, the u prime. We can go ahead and do the other side now. Let v equal to 3 3 minus x cubed. So 3 minus x cubed, after differentiating them, we'll get minus 3x square, which is easy. Alright, then we will be putting all the equation into all the functions, all the functions. So over here we have minus here, so it will, since there's a minus sign here and then minus 3x square, it will become positive eventually. So it will become 3 minus x cubed 3 cot 3x plus 3x square ln sine 3x over 3 minus x cubed to the power of 2. So we can simplify it a bit more by taking out the 3 cot here. So it will become 3x, it will become 3 bracket 3 minus x cubed bracket cot 3x plus 3x square ln sine 3x over 3 bracket 3 minus x cubed square. You can actually expand it more, but it will not look as neat. So this can be your final answer. Thank you.
Next, for the question number 3. So these are the questions and how to solve. So given y ln 2x minus e power of 3x minus 7 minus sin 4y equal to 2x squared minus 9. So we need to find dy over dx using implicit differentiation. So first, we will separate all of this number. So step 1, we're going to differentiate y ln 2x. So we use product rule, which is d over dx uv equal to u prime v plus uv prime. So u is equal to y and v is equal to ln 2x. So u prime we get dy over dx, and then v prime we get 1 over x. So basically 1 over 2x is inner function, and then multiply by 2 is outer function. So the derivative becomes dy over dx ln 2x plus y over x. So this is the answer. So step 2 is we're going to differentiate negative e power of 3x minus 7. So we use chain rule, which is d over dx eu equals to eu multiplied by du over dx. So eu is equal to negative e power of 3x minus 7, and then u is equal to 3x minus 7. So the derivative becomes negative e 3x minus 7, and then multiply by 3. So basically 3 we get from u is equal to 3x minus 7, and then we differentiate it, and then we get 3. So this is the answer. So step 3, we're going to differentiate negative sin for y. So we use chain rule because the inside is for y. So the derivative of negative sin is negative cos. So the derivative becomes negative cos 4y multiplied by 4 dy over dx. So basically 4 we get from 4y, and then dy over dx we get from implicit differentiation. So we get negative 4 cos 4y dy over dx. So next, step 4, we're going to differentiate the right hand side, which is 2x squared minus 9. So we get 4x. And then step 5, we combine all the results from step 1 to step 4 until step 4. So we get dy over dx ln 2x plus y over x minus 3 e power of 3x minus 7 and negative 4 cos 4y dy over dx equal to 4x. And in step 6, we isolate dy over dx. So we move the y over x and negative 3 e power of 3x minus 7 to the right side, and then we get this answer. So next, step 7, we're going to factor out dy over dx. So left side, we're going to factor out dy over dx, and then we get these answers. So step 8, solve dy over dx. So we're gonna leave dy over dx alone. So these numbers we move to the right side. So we get the final answer is dy over dx equals to 4x minus y over x plus 3e power of 3x minus 7 divide by ln 2x minus 4 cos 4y. So that's the final answer. Lastly, question 4. So the question is, use linear approximation to estimate the value of 4.02 squared minus ln 4.02, correct to 3 decimal places. So this is the formula of linear approximation, which is fa plus h approximately equals to fa plus f prime ah. So basically a is the point you expand around, and then h is the small change from 4 to 4.02. So based on the questions, so a is equal to 4, and then a plus h is equal to 4.02. Therefore, h is equal to 4.02 minus 4. So we get 0.02. Next, we're going to estimate 4.02 squared minus ln 4.02. So let fx equals to x squared minus ln x. So step 1, we're going to find f4. So we use f function, and then we replace it with 4. So we get 16 minus ln 4. So step 2, we're going to find derivative of f prime x. So we get 2x minus 1 over x. So basically we differentiate f function, and then we get f prime x. Then we evaluate at x equals to 4. So f prime 4 equals to 2, 4 minus 1 over 4. So we get 7.75. Step 3, we're going to use linear approximation formula. So f, which is f 4.02, approximately equals to f4 plus f prime 4 multiplied by 0.02. So we compute the change, and then we get 0.155. So lastly, step 4, we compute the approximate value, which is f 4.02 approximately equals to 16 minus ln 4 plus 0.155. So the final answer is f 4.02 approximately equals to 14.769. So that's the final answer.
We can therefore state that differentiation is an essential concept in calculus that helps us understand how various quantities change. Through various techniques such as the product rule, quotient rule, and the chain rule, we can find the derivative of many types of functions, from simple algebraic expressions to more complex logarithmic, exponential, and trigonometric forms. These methods allow us to solve real-world problems, estimate values using linear approximation, and analyze relationships between variables effectively. Overall, differentiation is a powerful mathematical tool used widely in science, engineering, and everyday applications.